Mr. Covey here, and we're going to be talking about how to solve quadratic equations using three different techniques. So this should be review from Algebra 1 as well as Algebra 2. So I hope this comes back to you quick. We're going to kind of do this all in one video. So first, take, this is in your note packet, by the way. First, take about 30 seconds and see if you can evaluate these three square roots. If possible, without a calculator. If you want to use calculator to check or help you out, you can. Okay, take about 30 seconds to do that, please. Okay, that's what you should have gotten for those three. Just wanted you to remind you about what a square root is. Square roots are the opposite of squaring. They're the inverse of squaring something. Okay? The reason I bring up square roots is they're a way to solve quadratic equations. Okay? As a reminder, these are equations. Why are they equations? Well, they're equations because they have an equal sign. And why are they quadratic? It's a vocab word I need you to know. Quadratic means they have a squared. Okay, they have an exponent of 2. If they have a squared, they're called quadratic. So if you want to get the x by itself, you want to solve this equation, you can square root both sides. Okay, so you can get rid of that squared by square rooting. But what you do to one side, you got to do the other side. You can square root both sides, type the square root of 75 into your calculator, and you get 8.66. Okay. Now, one other thing, don't forget, every time you do a square root, you need to add a plus or minus. Okay, so there's actually two things that squared equals 75, 8.66, and negative 8.66, because remember, a negative squared ends up being positive. Okay. Go ahead and take 30 seconds to solve these two. Yeah, that's what you should have gotten for those other two there. Just wanted to remind you, with the plus or minus, it means one answer is plus and one answer is minus. There's two answers. So quadratic equations usually have squared, or sorry, they always have squared, and they usually have two solutions. There's two x values, there's two answers to them. Okay? These three quadratics we solve are actually really easy. There's a little bit more complicated ones. And so maybe we should look at a couple of those. Actually, I'll tell you the steps first. So the steps for solving a quadratic using square roots are get the squared thing by itself. Okay? You get the squared thing by itself, you square root both sides. You don't forget, as soon as you square root both sides, to put a plus or minus. And then sometimes you're done there, but sometimes you have to get x by itself still. Okay. I'll run through a couple more examples here. So make sure you got down those steps there. Okay. So let's do this one. Get the squared thing by itself. What is squared in this problem? Well, it's actually the x that's squared. How do I get the x squared by itself? Well, I divide both sides by 5. I get rid of that 5. So now I have 4 equals x squared. What do I do now? I square root both sides. Add the plus or minus right there. And then I still have to get x by itself, but in this case, I already got x by itself. Why don't you do number 8 by yourself real quick? Okay. Had to get the x squared by itself, get the squared thing by itself, so I added 9. Then I had to divide both sides by 81. Once the square thing was by itself, square rooted both sides. So that's kind of what I didn't show there. Right here, I square rooted both sides, and I didn't forget the plus or minus. Okay, so those are my two answers. Let's solve number 9 together. So I'm going to get the squared thing by itself. I'm going to subtract 50 from both sides. I got 2x squared equals negative 50. Divide both sides by 2. X squared equals negative 25. And I hope you're thinking, well, this is kind of weird. But if not, let's keep going. Let's square root both sides. Go to your calculator. Type in the square root of negative 25 into your calculator. And it says error. It says error, non-real answer. Okay? And that's because you can't square root negative numbers. Okay? Now, you could talk about imaginary solutions, but we're not really going to talk about that now. For our purposes, I just want you to say we were squaring a negative, so there's no solution. Okay. Number 10 is a little tricky. what is being squared? This whole thing is being squared. Okay, I'll erase that so we can see it better. So the x plus 2 is being squared. So if you go back to our steps, get the squared thing by itself. The squared thing's by itself. Okay, so your first step should be, we got the squared thing by itself, we're done with that. Square root both sides. We're ready to square root both sides. Don't subtract the 2 first. The 2 is part of the squared thing. So our first step here is to square root both sides. Okay, go to your calculator, figure out what the square root of 10 is. Sorry, give me a second. You get 3.16. So then you have x plus 2 equals 3.16. Next up, add the plus or minus. You put the plus or minus right there. And in this one, we've been done a lot at this point, but in this one, are we done yet? Did we solve the equation? No, the x isn't by itself. So what's the last thing I do? I gotta subtract 2. Now here I have to be a little careful. I have plus or minus 3.16 minus 2. I have to go to my calculator and type 3.16 minus 2 to get one answer. And I have to do negative 3.16 minus 2 to get the other answer. Okay, so we really need to actually go through the process and remember that plus or minus means one's positive, one's negative. And here are our 2 solutions. Okay. So what was weird about 9? We were square rooting a negative. We're really not going to get into imaginary numbers. Okay, so we can skip those things for now. All right. We're going to come back and do some practice with this later, so you can just leave that for now. And I want to talk about this problem. Okay, so I hope you look at this equation, and if you try and go about getting the squared thing by itself, you'd subtract the 6x and the 8 over, and you'd be here. And now you'd try and square root both sides, and this is getting really messy. We have an 8 there. Well, this is really messy. That's because we're not going to use square roots here. So like this extra term here, the fact that we don't just have like an x squared and a number, but that we have this x term, is going to mean we can't use square roots to solve this equation. So I hope you remember factoring as an alternative way to solve quadratic equations. Okay? So if you look at this quadratic, it's got an n squared, an n, and a number. In order to solve this, we're going to factor it. I hope this is coming back from Algebra 1 and Algebra 2. We're going to put an n and an n there. And we're looking for 2 numbers to put here and here that multiply to 5 and add to 6. What are some things that multiply to 5? 5 and 1 multiply to 5. Do they add to 6? Yep. So I do n plus 5 and n plus 1. And since it is factored now, what you do is you set each factor equal to 0. So since n plus 5 is one factor, I set that equal to 0 and solve it. And since n plus 1 is the other factor, I set that equal to 0 to solve it. Subtract 1 from both sides, I get negative 1 here. Subtract 5 from both sides, I get negative 5. Again, I'm getting out 2 answers here. Okay. I hope this process of factoring is coming back to you. Let's do one more together, and then we're going to save some of this for some practice. Okay. One thing I should mention about factoring, make sure you remember it needs to be equal to 0 before you try and factor. In this case, it's already equal to 0, so we're good. So we're ready to start trying to factor. It's always going to have a v and a v there. And try to think of 2 numbers that multiply to negative 20 and add to, well, there's not really a number there, but remember, if there's no number next to a variable, it means there's a 1 there. So I'm looking for 2 numbers that multiply to negative 20. You can write this out. Multiply to negative 20. Add. Use your calculator here to figure out what 2 numbers multiply to negative 20 and add to 1. If they multiply to negative 20, one's positive, one's negative. If they add to 1, then the numbers are really close, but one's 1 bigger than the other. 1 bigger in terms of without positive negative. What are the 2 numbers? They're going to be 5 and negative 4. So how does this factor? V plus 5, V minus 4. Set v plus 5 equals 0, solve. Set v minus 4 equals 0, solve. You get your 2 answers. Cool. I hope this is very, very familiar. Okay. Take a second to try just do 3 and 4 real quick. Okay, so for this number 3 here, you should have said what multiplies to 20 and adds to negative 9. If it multiplies to 20, adds to a negative, then both numbers must be negative since they multiply to add to a negative. Those numbers were negative 5 and negative 4. For number 4, two numbers that multiply to 2 and add to 3, 2 and 1 multiply to 2 and add to 3, so your answer should have been negative 2 and negative 1. Don't forget that you got to flip them after you factor to get the actual answers. I just wanted to mention actually one special factoring situation, and that's if you come across a problem like this. You're like, 1,000x squared plus 5,000x plus 6,000? This seems really hard to solve. Well, there's an easier way. Okay, and what that easier way is to say all 3 of those numbers are divisible by 1,000. So you can take out the 1,000. And when you take out the 1,000, you're left with a quadratic that's much easier to solve. And you can kind of just forget about the GCF. You don't need to cross it out, but it just doesn't come into play. That is called a greatest common factor, GCF. Okay? So then you can go from here and just solve this equation. Well, I can solve that. What multiplies to 6 and adds to 5? 3 and 2 multiply to 6 and add to 5. Okay, so you're there, and your 2 solutions would be negative 3 and negative 2. So I just wanted to remind you about this idea. What's the greatest common factor? It's the biggest number. That everything is divisible by. Why is it called a greatest common factor? Well, the name is actually really telling here. It's called a greatest common factor because it's the biggest. What's a factor? Well, factors are things that go into something, numbers that you can divide something by. And it's called the greatest common factor because all of the things have to be divisible by it. Okay? And I hope this is all looking really familiar. What's the greatest common factor of 18 and 6? What's the biggest number you can divide them both by? You can divide them both by 6. What's the biggest thing these have in common? So we're going to have to do this 2 different ways. We're going to have to first think about the numbers. What's the biggest number you can divide 24 and 18 by? And you can use your calculator to figure this out. You're going to get 6. And then this has an x squared and this has an x. So what's the most you could take out of both of them? Well, just an x, because you can't take an x squared if you only have an x here. So the biggest thing you could take out of both of them would be an x. Here, 14xy, 2x squared. So the numbers first. 14 and 2, what's the biggest thing you can divide them both by? 2. xy and x squared. What do they have in common? What's the biggest thing, the most they have in common? Well, they both have an x. They don't both have a y, they don't both have an x squared, so we can't take out any more than that. And so that would be the greatest common factor. I hope this is really coming back to you. When should you check if there's a greatest common factor? When you're trying to factor and the leading coefficient is not 1. Either the leading coefficient is the number in front of the x squared. So if the number in front of the x squared is not equal 1, you should try and look for a greatest common factor. I'll do a couple with you real quick here. So if you look at this and we're trying to factor it, you should look at it and go, oh, I got a number in front of the v squared. So let me see what I can take out of all 3 of these. You can use your calculator and see 3, 27, negative 27, and negative 30 are all divisible by 3. So I can take out the 3. What am I left with? In other words, you should think about dividing all of these by 3. That's really what we're doing, okay? When you divide 3v squared by 3, you get v squared. When you divide negative 27 by 3, you get negative 9v. When you divide negative 30 by 3, you get negative 10. After you take out the GCF, you still finish factoring. Okay, so the thing you're left with on the inside, you still need to factor. Okay? So this thing here, we're going to factor. And we're going to leave that 3 out there and not worry about it. With that inside part, so it multiplies to negative 10 and adds to negative 9. Negative 10 and positive 1. Okay? Notice it didn't actually ask us to solve an equation. This wasn't an equation. It wasn't equal to 0. It's just asking us to factor. Okay, so make sure you keep in mind the difference between solving an equation, which is when you have an equal sign, and you actually figure out the answers. So there'd be another step here. And when it's just asking you to factor. Okay, so since it's just asking you to factor this one, there's no equal to 0, we just stop right here. Okay. Let's just do one more of those together. These 3 numbers, what are they all divisible by? You can use your calculator. Figure out they're all divisible by 6. Pull that 6 out. We're left with n squared. So when you take out that 6, you're left with n squared plus 9n plus 32. And then you try and factor this. Okay, so what multiplies to 32 and adds to 9? Well, you can think, and you can think, and you can think. Well, in this case, you actually can't factor it anymore. After you took out that greatest common factor, we were done. Oh, wait, I'm sorry. Why did I say 9 there? That was a silly Mr. Covey mistake there. Nobody even said anything. That was bad. It's 12. Okay. So now we can keep factoring. Oops, sorry, guys. Multiplies to 32 and adds to 12, 8 and 4. N plus 8, n plus 4, and we still have the 6 left on the outside. Cool. Last thing I want to remind you about is what to do when it doesn't factor. Okay, so if you're solving a quadratic equation, again, it's quadratic because we got a squared, it's an equation because we got an equal sign, and it does not factor, what do? You got to use quadratic formula. Okay. As a reminder, this is what quadratic formula is. I will provide you with this. You don't need to memorize it. You do need to know how to use it. So you'll notice it has an A and a B and a C in it. When you have a quadratic, before you do quadratic formula, you need to move it all over to one side so that it's equal to 0. Okay, so you got 9n squared. You got to subtract the 7n over, and you got to subtract the 4 over. So you got to make it all equal to 0. Then the first thing's A, the second thing's B, the third thing's C. And you got to plug it all in, okay? So if you plug it all in, it looks like this. Negative 7 plus or minus the square root. Negative 7 squared minus 4 times 9 times negative 7. All over 2 times 9. I recommend simplifying this in a few steps. While you type it in your calculator, you can definitely use your calculator here. First, I'd type all this into your calculator. Again, the parentheses there are important. You need to go to your calculator and type in, I think my calculator ran out of battery. Just kidding. Type in negative 7, or sorry, type in parentheses, negative 7 squared minus 4, parentheses 9, parentheses negative 7. I'm only typing in part of it. I'm typing the thing under the square root, and I get 301. So I'm going to do this in a few steps to make sure I don't make any errors. Negative 7, that's positive 7, plus or minus the square root of 301 over 2 times 9. What's 2 times 9? 18. Now I'm going to type this into my calculator, and you type it in twice, once with the plus and once with the minus. Please look where I'm putting parentheses. 7 plus the square root of 301 divided by 18. Look how I wrote that. I had to put the numerator in parentheses here. Otherwise, it gets messed up. Okay, you guys be careful with your calculator. I get one of my answers is 1.35. Okay, I'm going to do the exact same thing. At the exact same thing in there. If you hit second entry, it pops it up again. Only now I'm going to type it in with the minus. Instead of plus, I'm going to do minus, and I'm going to get negative 0.57 as my other answer. Okay. These, again, I'm getting two answers as always. Those are my two answers, okay? I will give you quadratic formula. I just need you to be able to plug in and get out your answers. Why don't we do one more together, okay? Actually, why don't you give this one a try, and I'll kind of run through it afterwards. So give this one a try right here. I'll give you a piece of advice to start. We got to move everything over to one side. Let's move it all over to the left side. So we're going to get 2k squared. So we got to move that over. Oh no, I'm sorry. We're going to get 4k squared. What am I talking about? We're going to add the 2k over. We're going to add the 2k over. So I'm actually not going to have any k's. Add the 6 over, add the 6 over. I'm going to get minus 25 equals 0. Be careful here. There's a k squared, there's no regular k. So if I want to use quadratic formula, it might be helpful to write it like this. How many k's do I have? 0 k. Okay. Here's my a, here's my b, here's my c. Go ahead and finish this up with quadratic formula. Okay, so once you got your A, B, and your C, here's me plugging in the quadratic formula. I typed this part into my calculator, and I typed -0, which is just 0, plus this square root in parentheses divided by 8, -0 minus this square root in parentheses divided by 8, and I got 2.5 and -2.5 is my two answers. Okay. All right. I hope all three of those techniques are familiar to you, and we'll practice them during class, don't worry. Cool. All right, that concludes this video. Thanks for watching.